Hi everyone. Well, I made a video with my class today, and unfortunately, I um, didn't have the audio on, so I'm going to be basically narrating what I'm doing in class today. Hopefully, that'll produce both audio and a transcript. So, in class, we talked today about this article from The Guardian, where Samuel Alito, who wrote the majority opinion on the most recent Voting Rights Act ruling, cited some data about Black voter turnout in the United States and in Louisiana. And we had a discussion in our class about the data that Alito used in his opinion and had some conversations about that data. So I'm going to skip ahead a little bit to our sets of questions. I had the class talk in small groups about the data that the Guardian included in this article and what the Guardian said about the data that Alito included in his opinion. Okay, so the first question was in terms of the data that was presented in the opinion, um, in Alito's opinion, what data was true in Alito's opinion? And our class said that, well, it was true that in two of the past five, or at least in 2012, the turnout was higher among Black voters than among white voters at the national level in the 2012 presidential election. And here we actually made an error when we talked about the denominator used to calculate the turnout. So I will point that out once it appears on the screen. So it was true that the turnout in 2012 was higher among Black voters than among white voters, both nationally and in Louisiana. Um, when the denominator for the voters were all adults 18 plus. And initially I wrote all adults or all citizens of voting age. And but what Alito wrote used data where it was all adults 18 plus, which of course does not include citizens, or sorry, does include non-citizens. So the point I made from this piece is that you don't have to lie in order to use statistics to present a certain viewpoint. Nothing that Alito wrote in the brief was factually incorrect, and yet the data that Alito chose to include, the Guardian argues, was very misleading anyway. The next question was, what data was overemphasized in Alito's opinion? And this is where we started digging in a little more deeply. So Alito made the strong claim, let me jump forward a little bit, that as I wrote this as we were discussing, and so I changed things a little bit. So here we go. I'll wait for myself to type that out. So Alito made the strong claim that because in two out of the five past presidential elections, national turnout among Black voters, and this should be using the all adults 18 plus denominator, was higher than among white voters. And therefore, Alito claimed that turnout parity, this two out of five ratio, showed that major racial voting barriers no longer existed. So that was really the crux of Alito's argument in terms of the data, that since Black voters had a higher turnout um, nationally than white voters in about half of the most recent presidential elections, therefore there must no longer be major racial voting barriers. And so we picked this apart a little bit. First of all, as an aside, I noted that this is a question about binomial probabilities. And so we can actually investigate this a little more statistically if we want. But I think a good starting point is just to point out that 2 out of 5, that doesn't necessarily imply parity. That's a pretty small sample size. It's hard to make any conclusions with just 5 data points. Of course, when it comes to presidential elections, it's also hard just to get enough data points. There are only about 12 elections going back to 1965 when the Voting Rights Act was passed. So even if they looked at all those elections, they would only have 12 data points, and that's pretty small for any kind of real statistical analysis. The other thing we discussed is that Alito's claim, at least the Guardian's representation of his claim, was that the 2 out of 5 proved that major racial voting barriers no longer existed. But that's a causation argument. And as we've talked about in statistics, statistics cannot prove why something is the way it is. So a very simple counter argument is that, well, the reason there were 2 out of 5 recent elections where Black voters had a higher turnout was because of the Voting Rights Act. And they only got to parity because of the Voting Rights Act. And therefore, taking the Voting Rights Act away would change the proportion in the future. Again, that's really a correlation versus causation fallacy. So that's what we discussed in terms of what was overemphasized in Alito's opinion. Of course, it's true that based on the way that or the data that Alito analyzed, 2 out of 5 elections had higher national turnout among Black voters. That's not true, but it's really been overemphasized in Alito's argument. And then the next question was, in terms of the data that was presented, what was underemphasized or left out of Alito's opinion? And again, this all voting age citizens is not accurate. And this is where I think I'm changing it. There we go. All adults 18 plus. I'm fixing it on the other slides. This slide deck, by the way, is available. You can link to it from the course page in the week 7 module. So what data was underemphasized or left out of Alito's opinion? The first thing that my class pointed out was that the denominator used in the analysis, which was all adults 18 plus, is not typically used for voter turnout because it includes people who are not eligible to vote, such as non-citizens. And differences in racial groups can lead to misleading conclusions. If certain racial groups have a larger share that aren't eligible to vote, it's going to change the proportions in ways that are misleading. So the generally accepted standard for this kind of analysis is to use citizen voting age population. And with that as the denominator, it changed the results significantly. We'll see a picture of that later. So the second thing that was underemphasized or left out of Alito's opinion, and for me, this is really the major flaw in the use of the data, the major misrepresentation, is Alito focused on the binomial question. 2 out of 5, that's binomial. But there's a lot more information that Alito's opinion could have relied upon, or at least the data could have looked at. So Alito ignored both the trend, which we'll take a look at in a minute, and also the quantitative variable questions. So binomial, you can turn any variable into a binomial variable. You just say, is it yes or no? Did Black voters have a higher turnout? Yes or no? But when you do that, you throw away a lot of data. The trend that we'll see in a minute, and also the quantitative data is being thrown out by this analysis. So here's a graph showing not just the binomial data, but also the trend and also continuous data. So we can see that there are two dots, the first two, where Black voters appeared to have a higher turnout. But after that, in the next three, not only did Black voters have a lower turnout, but the gap increased more and more. So there's definitely overall a downward trend in Black voter representation compared to white voter representation. And the binomial analysis loses that context completely. The other thing to point out is it's a little hard to see. It's easier to see on this picture over here. The shaded purple, light shaded purple, and the light shaded yellow, these are confidence intervals. And the left graph has them too. They're a lot more narrow. But just by looking at that first dot, it's really easy to see that the confidence intervals overlap so much that there really is no statistical difference in the turnout in 2008. And so even claiming that it was 2 out of 5 is quite a stretch. 1 out of 5 would be more accurate. So if we wanted to really talk about the trend and the quantitative data, what we would say is in 2008, turnout was nearly identical. In 2012, black voter turnout was higher, but in the following election, it flipped, and then the gap has grown in the most recent two elections. And you can see from the confidence intervals that there's definitely a big difference between this 59% compared to the 67% in actual quantitative data for the turnout. I think I'm talking more about what I just talked about here. There's that statistically significant difference part. 2 out of 5 is in itself misleading. I mean, if Alito used a different denominator, it might have looked a little bit bigger. But with the generally accepted denominator, 2 out of 5 is very misleading. So the final question was, I asked my class, how do you think data should or shouldn't be used in an opinion about the Voting Rights Act and redistricting? This was a more open-ended question, and I think was a little harder to answer, but one student basically said that methodology is important because the hardest part of doing good statistics is collecting good data. So, for example, was this enough data? Only 5 years? Probably not enough. Was it the right data? Using the adults 18 plus? Probably not the right data. And another question that I actually brought up was this national data here, right? The one on the left is national data, but that includes all 50 states. And the Voting Rights Act was specifically to protect the right for Black voters to vote in states that had enacted Jim Crow laws, which were basically the southern states. And so by including northern states, western states, midwestern states, it may be over exaggerating the actual turnout among Black voters. And maybe a better analysis would be to limit this analysis, not to nationwide, but maybe just to states where the Voting Rights Act was actually enforced or in force. So that was this comment here. Was it the right data? First of all, the denominator, and second of all, should they have looked at all 50 states? Let's see. And then another student raised the point that the Guardian said the agency that analyzed the data, which I think was the administration's Department of Justice, is basically accused of already having an agenda. So it's really important when you're going to analyze data, A, you have to be transparent, and B, when it's a really important issue like voting and the rights of all American citizens to have a say in choosing their government, it's really important that the data is analyzed transparently and by a group that does not have an agenda, whether liberal or conservative, Democratic or Republican. It really needs to be a nonpartisan agency who's analyzing that data. So I thought these were great points about the methodology. Were there others? Yeah, so I added this. What questions do you ask of the data? And this really gets back to, do you just ask a basic binomial question, thereby throwing out relevant information? Or do you ask a question that uses all the available relevant information to give you more detail and more understanding? And I am of the opinion that the choice on Alito, or at least the data he analyzed, to only use the binomial was a choice in furtherance of a particular viewpoint. Because the only reason you would not choose to include relevant information is, in my mind, if you didn't want to have an open and honest discussion about what that information was. Of course, there are lots of times when you have data that's not relevant, and therefore it's appropriate not to analyze it. But I would argue that the trend and the quantitative differences are both very relevant information when talking about voter turnout over time. And then I added a few more thoughts here at the back end. Here we go. So my thoughts, what would it mean to use this data in a statistically ethical way? And what I said is that historically, data has been used by statisticians to oppress various groups in lots of different ways, whether that's a group identified by a racial or ethnic group identity, or cultural, or country of origin, gender identity, sex. Lots of different groups have been oppressed by statisticians using data in unethical ways. And therefore, I think it's really important not to use data in a way that oppresses different groups. The crux of the majority opinion in this case was basically that it is illegal to draw districts to benefit any group based on race, but it's completely legal to draw districts in a way that benefits any group based on political orientation. Therefore, it would be completely legal for a state legislature to redraw districts that disenfranchise Black voters, as long as they say, we're not doing it to disenfranchise Black voters, we're doing it to try to get more Republican votes. It would be illegal for a state or the federal government to say, you need to draw a district that ensures that Black voters have an equal opportunity to vote, because that is drawing a district based on some racial identity. My personal opinion is that doesn't make sense, but that is, I mean, I'm not a legal scholar. That doesn't make moral sense to me, but that's the legal argument that's being made in the majority opinion. I'm also, I only have a very basic understanding of the nuances, so there may be deeper nuances, but that's the general idea. So my argument, as I was writing these notes down, is if the majority opinion is that race cannot be considered whatsoever in this decision, in drawing voting districts, then why would you even analyze race if the argument is only about what is allowed for political reason? So don't use racial data to oppress groups based on race. Don't use data in ways that oppress groups. That's kind of my basic thesis for how to do ethical statistics. I will have a question on your next quiz that asks probably specifically about this graph here on the left. And the question will be something like, the majority opinion in the Voting Rights Act case referenced the fact that 2 out of 5 of the most recent presidential elections had higher voter turnout among Black voters. And therefore, the racial parity gap was closing, or no longer existed. respond to that claim using this visual and representing as a statistician who has had ethical training, something to that effect. I said it much more eloquently today during lecture. So that was one of the reasons I wanted to record this conversation, was so that all of you watching this video know that it is very important to read this article, to understand the article, and to be able to speak clearly, ethically, and statistically about this visual here and what it means in terms of voter turnout, barriers to voting, ethical use of statistics, etc. All right. And then I hopped back and I talked about one more interesting thing, setting aside any of the context, any of the Voting Rights Act, the opinion. I just looked at these graphs themselves and I pointed out that the confidence intervals over here on the right are much bigger than the confidence intervals over here on the left. And I asked the class to discuss why is that? And the answer was because on the left, it's a nationwide count of voters. So we're talking 300 million voters. And even among these subsets, that's about, I believe, about 15 million Black voters nationwide. That's going to give you fairly narrow confidence intervals because you have a large data set. Over here on the right, it's Louisiana only. So we're talking about far fewer, I mean, still a lot because there's millions of people in Louisiana, but relatively speaking, far fewer people, a smaller data set, and so your confidence intervals are going to be wider. You can shrink your confidence interval by collecting more data. And that led me into the mini lecture from today, which was basically a brief review of the ideas from confidence intervals. I'm going to jump ahead a little bit, look for places where maybe I'm not writing, and then I'll talk about it. Nope, that's too far. Okay, so a review of confidence intervals. A confidence interval has three parts. It has a best guess, which is the sample mean, or X bar. It has a reasonable range, and you find the minimum by taking the sample mean and subtracting off 2 times the standard deviation of the sample means. And then the maximum on the reasonable range is the sample mean plus 2 times the standard deviation of the sample means. And of course, every confidence interval should also include a confidence level. Here we go. And usually we use 95%. We could use something higher. We could use 99%. We could use something lower, like 90%. This graph uses a 90% confidence range, right? Because a 95% would have been even bigger. There are two ways to make a confidence interval smaller or narrower. What did I write? I wrote smaller. The first way is you can decrease the confidence level. A 90% confidence level will be narrower than a 95% confidence level. Another way is to gather more data. That allows you to make a smaller confidence interval without changing your level of confidence. And that is, of course, exactly this picture here. With more data, the confidence intervals are going to be smaller, even with the same level of confidence. What did I write next? Confidence intervals only tell you about the parameter that you are estimating. Now, in this class, we focus on estimating the mean, but you could estimate a proportion. Again, that's what these confidence intervals are estimating. They're estimating the proportion for each national turnout the ratio or the proportion of black voters who voted, et cetera. So you can do a proportion, you can do a standard deviation, you can do any population parameter. We're going to focus on the mean. But the point is, confidence intervals can only tell you about the parameter that you are estimating. They can't tell you anything else about the sample or the population itself. And so I talked through an example of that. Suppose you create or calculate a 95% confidence interval for the average weight of cats. I like to use the word average instead of mean because average is common plain language. And suppose that you find that the 95% confidence interval is 10 pounds plus or minus 1.2 pounds, which, by the way, is a perfectly good way to write a confidence interval. You can say what the best guess is plus or minus the margin of error. Or you can write it as an actual interval, which in this case would be 8.2 up to, sorry, 8.8 up to 11.2 pounds. And then I posed a couple questions. First, I said what this confidence interval implies. This confidence interval implies that I am 95% confident or sure. I think I forgot to write that word. I am 95% sure about the population mean. That's all I know. That's all I'm claiming is that I know something about the population mean. Does it imply, for example, that the maximum weight of a cat should be 11.2 pounds? The answer to that is no, because a single cat is a single observation. And confidence intervals don't tell us about single observations. They only tell us about means. So the maximum in a confidence interval is not telling you about a maximum for an observation. It's telling you how big you think the population mean could be. I think that's what I'm saying here. This is a very weird experience for me, trying to narrate over my notes, not knowing exactly what I was saying at a given time. So, no is the answer to that question. Next question. Does it imply that 95% of the sample I collected, right, of the cats in my sample, were between 8.8 and 11.2 pounds? And the answer to that is also no. If you think about collecting 30 cats, some are going to weigh more than 12 pounds, almost certainly, if you've got a nice random sample. And some are probably going to weigh less than 9 pounds. And probably more than just 5% are going to be out in those wider areas. So it does not tell you, again, about individual cats. 95% of the cats, that's a statement about individual cats. And a confidence interval only tells you about averages. I believe, if I remember, I drew a picture here. Here's my probability distribution or weight distribution for cat weights, centered at around 10 pounds, because that's my best guess. Might not be exactly 10 pounds. If I were to collect an actual sample of cats, let's say 30 cats, I'm going to find some that were well below 10 pounds, some that were well above, and yeah, a lot that were in the 10-pound range, but not necessarily all of them or most of them clustered very close to 10 pounds. It's going to be a pretty broad sample. But the average for that sample, well, when you average out all those dots, you're going to get something pretty darn close to 10 pounds. And if you were to do it again, you'd get pretty close to 10 pounds again. You might get a little more or a little less, but the averages of all those samples are going to be clustered pretty closely to 10 pounds. So you can see from this picture that the dots in the sample of 30 cats can be spread out quite a lot. But the stars, which are the average weights for each sample, those are clustered tightly. And that confidence interval there at the bottom, which I don't know if you can see very well because of this blue bar, but that says that's the confidence interval for the mean. It's only telling you about what you think average weights would be, not about individual weights. And that's it. That wraps up the lecture for today. Um, I hope this is intelligible to all of you who are watching and understandable enough, even though I was narrating over a silent film instead of speaking as the knowledge was being generated. If you ever need to make an appointment or ask questions in the discussion, you can certainly do that. So thank you for watching and have a good day.